How are we doing today? We are moving on. We are still kind of in writing equations. We're trying to expand our knowledge or the depth of knowledge on our formulas from our formula sheet and our ability to start pulling into these different sections that we've learned. And you're going to see some of this stuff starts to come up today, and we have to think and think carefully as we start to do these. So again, if you're looking at what we did in the past, 3.3, this is almost recaps 3.3, but also brings some real world examples and some word problems into it. So we're going to refresh your memory a little bit, and then we're going to get into those word problems. So creating linear equations in slope-intercept form, this particular equation is about when we're given a slope and we're given a point. First two things we always need to make sure we can find is what is the slope, a rate of change, and what is the y-intercept? And we have to be careful because sometimes they hide these things on us and we don't necessarily see them right away, but we need to make sure that whatever they give us, we look at it carefully, you analyze it and figure out, is it one of these two things? If they're missing one of them, we need at least those two things, a slope and a point. And if that is whatever they give us, we look at it and say, if it's not there, we need to find it. How can we find those two things from what they've given us? So determine if they give you a point, determine if that coordinate is actually a y-intercept. And remember, no matter what, guys, your your coordinates anyway. Let me make sure I've got this open. Signature. All right, comment. Here we go. There's my thing. A coordinate is, in its simplest form, an x and a y, right? In order to determine if the coordinate, the point that they give you, is a y-intercept, if it is, the x would be a 0, like 0, 5. That means this would be your y-intercept. Okay, so we have to be careful about that. Sometimes they like to sneak us in these little y-intercepts, and we may or may not notice it to start with. But we need to get more in the habit of checking out this information that they present to us. Did they give us a slope? If they didn't give us a slope, guys, they're going to give us two coordinates, and we have to use our slope formula to find the slope. Okay. Then what do we do is once we have this slope, once we have the y-intercept, we use those two to rewrite our equation. That equation, y equals mx plus b. It's used everywhere in real life. Okay. M is the slope, b is your y-intercept. Our goal is to find these two because once we find them, we can write the equation. The entire purpose of writing the equation of a linear function. Okay, let's see what they give us for our first example. It says, write an equation of a line that passes through the point -8, 6. Again, look, here's our x. There's your y. And has a slope of, well, they literally gave us the slope. This is your m. -3/4. Now, as we sit here, as we look at this, okay, we have to be careful. Because right here, is this coordinate the y-intercept? I know what my m is. I need b in order to write my equation. Is this coordinate b? Look, what's our x? Is this a 0? No. So we do not, they did not give us the y-intercept. We're going to actually have to find it. And to find it, we need to use this formula. Y equals mx plus b. We do not know what b is, but we do have x. We do have y. Here's the x. There's the y. And we have a slope. So we can plug all this in and start to figure out, solve for b. So the y is 6. I'm going to use law of substitution. Substitute the y for 6. The slope is -3/4. Going to remove our x coordinate from this equation, and the x was -8. Plus b You have no idea what B is. Now, guys, this is evaluating. You need to multiply these together. We are allowed to use calculators from the first day on our end of course exam. So we need to get good at using our calculators. On our calculator is a little button that looks like this, A, B, C. The mixed number button. This allows you to put fractions into your calculator. Notice, a negative times a negative is going to be positive. Great. We need to do this in our calculator. 8. Then you hit the times button. You're going to hit 3. You hit ABC 4. And it looks like this as we start to type in, like a little baby backwards L. When you do this, guys, it does all of the math for you. It's literally taking 8 and then it's multiplying 8 times 3 over 4. And all at the same time, it reduces the fraction for you. So 8 times 3 ABC 4. And we end up with 6. So we know that all of this turns into a 6. All right. Now, we're trying to solve for B. It means we need to get rid of this. If we have our scales, this is from our second unit. We subtract 6, so it cancels. What you do to one side, you have to do the other, the subtraction property of equality. And this cancels, so we have 0 equals B. Because it is okay to get 0 as an answer. That thing, it happens. We know what our M is now. We know what our B is. We're able to write our equation. Only this time we're substituting in the pieces we know. That goes in for there. This goes in for there, and you'll be good to go. -3 over 4x. Now, I'm going to use this loosely, plus 0. We would not write this in our equation. Plus B, our B is 0, plus 0. We don't write that, so our equation itself is just this right here. Right here, y equals -3/4 x. That's it. Okay. That's the easiest that they're going to give us. Of course, they will get harder. Write an equation in slope-intercept form. Oh, here comes a baking question. Baking. So this girl, Marissa, is baking a recipe that calls for her to turn down the temperature on her oven for part of the baking time. It says write an equation that represents the situation if the temperature in her oven drops 25 degrees every 30 seconds. And after 2 minutes, the temperature in her oven is 365 degrees. Notice what I did there, okay? We need to figure out, what do we need? We need a slope and we need a y-intercept. But in order to do that, we need to figure out what is our x, what is our y in this equation. Okay? So they're talking about two separate things, temperature in degrees and time. And they're saying that over time, time is affecting the temperature. So that means the time is here. This is our time. Time is the x, and the temp is your y. This part here, this even sounds like a fraction to me. If 25 degrees every 30 seconds. If this is your y's, remember our slope formula. M equals y2 minus a y1 over x2 minus x1. Our y's over our x's. Here's our y over your x's, your time. Be very careful on this one because this one there, they're trying to trick us on this, so we got to be careful. These are seconds. There's our slope. Did they give us a y-intercept? No, but they did give us right here a coordinate. 2 is the time, minutes, 350 degrees. Issue. Big, big issue. I know the first part, step 1 says determine what the slope is. Well, we say, oh, there's our slope, 25 over 30. Not exactly. Look at these. Notice they're giving us 2 different units of time. They love to do this to try to trick us. We have to pick a unit of measurement and stay with it. Okay, I usually like to go with the larger version of it. So what's larger, minutes or seconds? Oh, minutes. How many seconds are actually in a minute? Ah, that's right, 60. So we need to rewrite this in the same units. Okay, and if we do that, we have what? To get to a minute, we need to multiply this by 2 to get it to 60 seconds, right? And 60 seconds is equal to 1 minute. That means you also have to multiply the top by 2. So that's, and be careful. We got to look at this slope very carefully. What's happening to is this slope a positive slope or a negative slope? What does it mean if it drops? Drops is going down, right? So that's a negative slope, negative 50. There would be your slope. Now they say find the y-intercept. Well, this was not our y-intercept. So again, we have to use our equation from up here, y equals mx plus b. We're going to use y equals mx plus b. Plug in the pieces we know. We know m is negative 50. Our x was 2 minutes. And our b, or y, I'm sorry, or y, and our coordinate was 350. Now we evaluate. Here we go, these two here, negative 100. Now consider this again, we're trying to solve for b. So if this is a scale, and we need this piece to go away, how do we get rid of a negative 100? We add 100. And the addition property of equality states that if I add it to one side of an equation, I have to also add it to the other. And like that, these cancel and leave you with b. 350 plus 100 is 450. Now I know my m was negative 50. My b is 350. I'm able to do the last step, which is now write it in slope-intercept form. Y equals negative 50 x plus 450. All about finding the 2 pieces we need. And if you think of our equation, what's the missing piece? The m. What's the missing piece? The b. We have to use the information they give us to find these pieces. And then we can rewrite our equation once you get them. Individually, each step we're doing is not difficult, but it's when we have to put all these steps together to get an end result. This is what they like to say is compounded problems in math. Now, we look at our next example, and the first thing I want you to say is when you see something like this, right? I want you to think of something really. The first thing I want you to think of is that they just gave us a bunch of what? Yeah, it's data. Of course, we could say that. It's a bunch of coordinates. These are all individual coordinates, right? You could say these are all coordinates, a bunch of 5 of them. And when we have coordinates, we should always be very careful to look at. We want to, before we do anything, we analyze our data. As mathematicians, we analyze it, we look at it, what's going on. what's happening to our x's, what's happening to our y's. And I can see, oh, look, 2011. I didn't even read the problem yet, okay? 2011, 2012, 2013. These are going up by 1 every time. And these, well, these are not. Like this here is 4. And then we have what? It goes up by 1. And then it's up by like 70 something. And then it's up by 100. Guys, this. When your x's change by 1 and your y's are not changing by the exact same thing, this is not linear. Not linear. So it changes a little bit what we're doing, but not a whole lot. Because when we did our section 3.2 and we talked about slope, one of our problems they gave us was finding, it's called, instead of just the rate of change of the slope, the average rate of change. Average rate of change. Average rate. Now, to find an average of anything, you add up everything and you divide by the total. Well, it's sort of about the same thing, only we're doing the slope. So you want to use this coordinate and this coordinate when we find our slope. Okay, you always have to think about that. How are we going to get some sort of rate in order to write this magic linear equation that could possibly represent what's happening to this data? And we'll talk more about that too in just a second. So let's actually see what we're dealing with here. It says the number of students enrolled in public high schools in the United States has risen slightly since 2010. It says write an equation that could be used to predict the number of students enrolled in the high schools if this trend kind of continues. So we're using this like guesstimate. This isn't like concrete here. Notice if it was concrete, this y should have changed by an exact number every single time. It hasn't. So we're finding an average rate of change. To be more specific, what they want us to actually find here, it's called the line of best fit. It's sort of like a line that could be used to predict what's coming at any given point. We just have to be careful when we do this. And nothing changes. We need to find, first off, we're trying to write the equation of a line, even though this isn't a line that's exactly like the data we have, it can be fairly close and give us a prediction. So here we go. We need a slope, but I can't pick just anything. I need to find the average rate of change over the entire section that they gave me. I'm going to use these numbers here as my points. So our slope formula, M equals y2 minus y1 over x2 minus x1. I'm going to use our last point, this one, and our first point. So we're going to say, let's see, big division bar, minus sign, a minus sign. 14,000, 912, minus 14,000, 749. Okay, and then we have 20, the x coordinate that matches with this y is 2015 minus 2011, because these are x's, there's our y's. And 163 over 4. Well, again, you could use your calculator to reduce. Notice you're going to do 163 ABC4. It gives you a mixed number, and you hit the second ABC button, and it comes right back to 163 over 4. This is not, it doesn't reduce. If you put this in your calculator and just divide it, you get 40.75 as your slope. Guys, either way is acceptable because this is a terminating decimal. You could use it in decimal form. You can use it as a fraction. It doesn't matter. It's whatever you're comfortable with. And of course, how they want us to represent our answer in the end. So you have to read your directions carefully. Okay. Now we think about this again. We're thinking about writing an equation, y equals mx plus b. So now they want us to describe a method that we're going to use to complete this task. Well, I have a slope, and none of these here are a y-intercept. So the only thing I can do is, grab one of these coordinates and find it. So we're looking for y equals mx plus b. I'm going to use this coordinate here. My y would be 14,912. And there's more than one way to approach this problem. So depending on what you're doing, you may have done it differently. You might have given these respects as, year 1, year 2, year 3, year 4, year 5. I'm not. I'm using it as exactly as they gave it to me. They gave it to me as an x and a y. I'm using it that way. Our slope was 40.75. The x coordinate was, for that particular one, was 2015. I'm going to go in here. I'm going to say, okay, what is this? Let's see, 40.75 times 2015 gives me 82,000. 0.5. Again, we're solving an equation here. So I'm going to subtract this amount, 82,000. So we'll cancel. And I do that in my calculator. Negative 67,000. I have my B, I have my M, and we can kind of write our equation. Y equals 40.75 x minus 67,000 0.5. And now you could predict if they want to say, what's the average population going to be in, let's say, 2016, right? Because they want to know, like, what do you think this could be? Is this even accurate? Let's test it. If I take X and I replace X for the year 2016, which is only a 1-year difference. We haven't had any massive jumps in this. Plug this in. You're going to do all this in your calculator. 40.75 times 2016 equals, it's like 82,000 something, 82,152. Subtract 67,097.5. And you're ending up with like 15,054.5, so 15,055-ish. So this is, again, you can say, here's f of 2016. Again, using some function notation, if you wanted to use that. So we'll say 15,000, 0.55, because we round up, we're talking about people. Okay, look at our original table of values. That isn't, you're talking, that's not bad. You're spot on. You're within less than 100. And this is what's happening every time this is raised. It's either been under 100, started off very small, and it's slowly gotten a little bit larger as we've gone. There you go. This could be an acceptable amount. You could use this to keep predicting what the population is going to be. It's called the line of best fit. It allows you to project unknown values down the road, as long as you can find an average rate of change and use one of the coordinates they give you to create this y equals mx plus b, this linear equation. All right. Let's look at our last example. Our last example here is about jobs, cashola money. And again, it's going to bring something in from the past, our simple interest. lesson 3.5 is, I believe, where that one came from. So let's think about this carefully. Mr. Kimball sells computer software. Okay, he earns a base salary. He earns a base salary, and there's an important math term. And means plus in math, and 8% commission on his sales. Write an equation that represents the total amount of money he's going to pay, P, after selling D dollars. So P is our dependent variable. D is the independent variable. Because we never know how much he's going to sell. He could sell some today, he could sell some later on. Whatever he sells, they're taking 8% of it and adding it to his base salary. So there's our identified our variables and what they represent. Now we can start to write this equation. I'm going to write it just so we can see here. P equals M times D plus B. Remember, that's our X, that's our Y. Again, this is the X, this is the Y. They're just changed our variables on us. It's okay to do that. Now, we have to figure out this rate. Remember this little percentage? We don't like this. We can't use this in math. When we have a percentage, we have to take this and turn it into something we can use. So you take this 8%, and that's right. Same thing we did in our simple interest. The percentage has to be turned into a rate. We have to divide it by 100 and give it a mathematical value we can use, because not every calculator has a percent symbol. The ones we use in class do not have a percent symbol, so we can't just use a percent button. We have to turn it into the decimal. So you take 8 divided by 100, and what do we get? We get 0.08, which is our M. And all we have to do is figure out what's our initial value. Did they give it to us? If he sells nothing, no money whatsoever, does he have an initial value, a base pay? Yes, that's right here. No matter what, if he's a lazy louse and doesn't sell a single thing, he's still going to make $42,250. Whatever his sales are for the year, that's when they're going to sit there and tack on that 8%. So we can start to write our equation. We have all the pieces we need. This is our B. Ready? So there we go. 0.08 D plus 41,250. And like that, we finished this assignment. You are good to go. Get out there, guys. Our homework's in McGraw-Hill. Get it done. Hey, did you just try to call me? Hello?